Today, we shall be looking at binary operations. The word binary means two. Binary operations. We shall refresh on binary operations. This is an operation that combines two elements of a set according to a rule. The operation is denoted star or asterisk, as the case may be, or a delta symbol, or an addition symbol defined, or a multiplication symbol defined, as the case may be. Let's look at some properties of binary operations. Number one, the closure property. If A, B belong to S, and A star B also belong to S, then S is closed in star. In this regard, we're looking at the elements A and B are members of the set S. That is the implication of this statement. The second one is commutativity. If A is operated on B and is equal to B operated on A, where A and B are members of the set S, then the operator is commutative. The third one, if A is operated on B, the bracket open and closes, and then is operated on C, if this is equal to A operated on bracket open, B operated on C, bracket closes, then the operator is associative. If A is operated on B operated on C, they are different operators. And if it is equal to A operated on B star A operated on C, then the first operator distributes over the second one. Another important property is the identity element, or what we call the neutral element, E. If it exists for all A belonging to S, then A operated on E is the same thing as E operated on A, giving you the result as A. In this case, there is an identity element, E. The last one is inverse element. Say A inverse. For all A belonging to the set S, there exists an inverse element, A inverse, belonging also to set S. So that if you operate A and the inverse, it will be equal to the inverse operated on A, and the result is equal to E, the identity element. In this regard, when you have such relationship, then A inverse is the inverse element of the element of A in that set. Let us now look at examples on binary operations. Example 1. The binary operation star on the set of rational numbers is defined by A star B equal to B squared minus A squared all over 2AB. Find 3 operated on 2. Solution. We have 3 operated on 2. In this case, your A is 3 and your B is 2. That becomes 2 squared minus 3 squared all over 2 times 3 times 2. The result is 4 minus 9 all over 12. And that is equal to minus 5 all over 12. And that is the result of the operation. Example 2. The binary operation star on the set of Q of rational numbers is defined by S operated on Y equal to 8SY. For all S, Y belonging to the set Q, find the identity element under the operation star. Solution. Let me explain first of all what we mean by rational numbers. Rational numbers are numbers that can be expressed as fractions. 2 over 1, 3 over 1, 2 over 3, 4 over 5. Those are examples of rational numbers. Now, for this problem, we have S to Y is equal to 8SY. For us to find the element, the identity element under the operation, so let let E be the identity element. Take A to be the identity element. Therefore, S operated on the identity element, it must give you the result equal to S. Apply this operation on the given rule, that when you operate this on this, you will have the right hand side. So S is for 8, so our S here will remain as 8 is the constant there, multiply this by S, and the E now takes the position of Y, and that is E. Everything is equal to S. Now it is E you are looking for, so S can divide both sides, so we have our E is equal to S all over 8S, and that becomes 1 all over 8. So the identity element, therefore, E is equal to 1 over 8. Example 3. If an operation star on the set of integers is defined by A operated on B equal to A squared plus B squared minus 2A, then 2 operated on 3 in brackets operated on 4 equals dash. Solution. We have here 2 operated on 3 first, and that will be equal to 2 squared plus 3 squared. 4 plus 9 is 13. Then you now take the 13 operated on 4 to give you 13 squared plus 4 squared. 13 squared is 169, 4 squared is 16, and 6 plus 9 is 15, that is 5, carry 1, 2, and that is 8, and that is 185. That gives you the result of the operation. The result of the operation is equal to 185. Number 4. An operation star is defined on the set of real numbers by S star Y equal to S plus Y minus 2SY. If the identity element is 0, find the inverse of element P under tab. So solution, let the inverse of P be P raised by minus 1, that is the inverse. Then we are saying here that our P operated on the inverse is equal to E. Replacing S by P, as you have it there, so that means our P plus the inverse of P minus 2 times P times the inverse of P is equal to 0, because the identity element is equal to 0. Now, this means that our P 1 minus 2P is equal to minus 8. I have collected the terms involving the inverse of P together and factorize it, and so my inverse of P will be equal to minus P all over 1 minus 2P, and that gives you the inverse of this operation. Example number 5. A binary operation star is defined on the set R of real numbers by A star B equal to A plus B plus AB, where AB belonging to the real numbers R. Find the identity element under the operation star. You will recall that real numbers are integers that are both positive, negative, and also rational. Now, for this solution, we have here that A is operated on B, and the result is A plus B plus AB. Now, we are to find the identity element, so let E be the identity element. The identity element. Now, that should be the case, so A operated on E must be equal to A. In other words, we have A plus E plus A times E is equal to A. Now, if you look at this, you can isolate A here. So we have E is equal to 1 plus A, and then we have A minus A is equal to 0. Therefore, our E is equal to 0 all over 1 plus A, and the identity element is equal to 0. For an example also, we have a table here for us. The operator is defined by the asterisk, and we have the letters A, B, C, D, and then this other one A, B, C, D. Actually, this is the, let me put another line here to differentiate it, and put another line here to also differentiate that. So we are operating this on this to give us the result inside. So A operated on A is D, A operated on B is C, and so on and so forth. Using the operation table given above, find the identity element under the operation star. We want to find the identity element in this case. In our solution, let's say our identity element is E. And if you take A and operate it on E, the result will be equal to A. And a careful observation of the table, you discover that if you take our A and operate it on D, A operated on D gives you the result as well, equal to A. Then if you also take D operated on A, because it's reversed, will also give you the same result, then D operated on A also gave you A. Therefore, our D is equal to, okay, let's put it this way, therefore, E is equal to D. So this is the identity element of this operation. Example number 7. The binary operation is defined on the set A equal to 1, 3, 5 by P operated on Q equal to R, where R is the remainder when the product of P and Q is divided by 7 for all PQ belonging to A. Is A closed under the operation star? Solution. We will draw up a table of the outcome of this operation. The operator is this, and we have this element. The definition is that when you multiply two numbers and you divide by 7, you put down the remainder. 1 times 1 is 1, you divide by 7 is 0, remainder 1. This is 3, and this is also 5. 3 times 1 is 3, 3 times 3 is 9. 9 divided by 7 is 1, remainder 2. 3 times 5 is 15, 15 divided by 7 is 2, remainder 1. 5 times 1 is 5, divided by 7 is 0, remainder 5. 15 is 2, remainder 1. 25 is 3, remainder 4. As you can see, the element 4 is not a member of A. Therefore, A is not closed, under the operation star. For it to be closed, every element in the outcome must be a member of the set A. In this case, 4 is an element and is not a member of set A. Therefore, A is not closed. Question number 8. The binary operation star is defined on the set R of real numbers by S star Y equal to S plus Y minus SY, where S, Y belonging to R. Is the operation star commutative? Solution. For commutativity, we say that if S operated on Y is equal to Y operated on S, then we will say that the operation star is commutative. Now, taking a look at the left hand side, this becomes S plus Y minus SY. Now, we take a look at the right hand side. Our Y star S will be equal to, in that same order, we have Y plus S minus YS. Now, if you look at this very carefully, this can also be written as S plus Y minus SY. Therefore, the operation star is commutative. Operation star is commutative. You can see now that this expression here and then this one here, they are equal. That is why we say the operation is commutative. Question 9. A binary operation star is defined on the set R of real numbers by A star B equal to A squared plus B squared minus AB for all A, B belonging to R. Solve the equation. 4 star S equal to 28. Our solution, our 4 star S is equal to 4 squared plus S squared minus 4 times S. And that means 16 plus S squared minus 4S, and this is equal to 28. Giving us S squared minus 4S plus 16 minus 28 equal to 0. So that this is S squared minus 4S, and then this is minus 12 is equal to 0. And then this factorized to become S into this equal to 0. Let's see, since this is minus, so this will be plus. Plus 2 minus 6 is minus 4. Therefore, S plus 2 is equal to 0, or S minus 6 is equal to 0. The result is that S is equal to minus 2, or it is 6. So with this, we have found the value of S. We have solved the equation to get the value of S. Here are the exercise on binary operations. Number 1, an operation star is defined on the set of real numbers by A star B equal to AB plus 2 into A plus B plus 1. Find the identity element. A minus 2, B minus 1, C 2, D 1. Question number 2. If the operation star on the set of integers is defined by P operated on Q equal to the square root of PQ. Find the values of 4 operated on 8 operated on 32. In bracket, open and close it. A is 8, B is 3, C is 16, D is 4. Number 3, a binary operation star is defined by A star B equal to A raised to power B. If A star 2 is equal to 2 minus A, find A. Answers are A, 1, minus 1, B, 1, 2, C, 2, minus 2, D, 1, minus 2. Question number 4. A operated on B is equal to A plus 3B. A operated again on B, look at the different symbol, is equal to 5B minus A, are defined on R. If S operated on Y is equal to 5 and S operated on Y again equal to 3, find S, Y. Option A, 8, B, 2, C minus 1, D minus 2. Question number 5. If S operated on Y is equal to S plus Y minus SY, find S when S operated on 2 plus S operated on 3 equal to 68. Options are A, 24, B, 22, C minus 12, D minus 21. For question number 6, here is another table for you. This is binary operation table of addition. And we have the table as you can see it here. Then in the table above, A operated on B is equal to A times B modulo 5. Find the identity element. There's a hint for you. Modulo 5 means the remainder when divided by 5. So in this operation, A star B is equal to AB. It's like 2 times 1 is equal to 2. So what is the value of 2 modulo 5? Now, that is what we have in the question. At the end, the identity element is A, 4, B, 3, C, 2, and D is 1. And question number 7, another operator star is there, and we have the numbers and the charts here. Now find the inverse of 4 in the table above. 4, the element of 4 has an inverse. Find the inverse in this table. The answers are A, 1, B, 2, C, 3, and D is 4. Question 8. Here's another table giving you the operations star on the elements, and this is the result. The table above shows the binary operation star defined as S star Y equal to SY minus 1. The value of m and n respectively are a 2 and minus 1, b minus 2 and minus 1, c minus 2 and 1, d minus 1 and minus 2. The answers are number 1, option B, number 2, option A, number 3, option D, number 4, option B, number 5, option D, number 6, option C, number 7, option D, number 8, option D.